Okay, we want to find the precision, greatest possible error, relative error, smallest possible value, and largest possible value of the following measurement numbers. So let's start by looking at 96 and 3/10 meters. We can see our rightmost significant digit is this 3 in the tenths place, so our measurement is precise to the nearest tenth of a meter. The greatest possible error of a measurement is always 1/2 of the precision. So 0.1 meters divided by 2 is going to give me 0.05 meters, and our greatest possible error is 5/100ths of a meter. Okay, to calculate the relative error, we're going to take our greatest possible error and divide it by the measurement itself. We're also going to take that times 100 to turn it into a percent. So this is something that I'll use my calculator for. I want to take, sorry for the ring light there, 0.05 divided by 96.3 and then times 100. My measurement had 3 significant digits, so I'm going to round this number to 3 significant digits. Notice these leading zeros do not count as significant, so my first one is 5, and then 1, and then 9. This 9 would round down to a 9, so I'm going to make this 0.0519% is my relative error. The smallest possible value can be found by taking my measurement and subtracting off the greatest possible error, which would give me 96.25 meters. And my largest possible value would be found by taking my measurement and adding the greatest possible error. That would give me 96.35 meters. Okay, let's do another one. Here, if we look at 520 inches, this time our measurement is precise to the nearest 10 inches because that 0 is not marked as significant. So our precision is to the nearest 10 inches. The greatest possible error is going to be half of that. Half of 10 inches is 5 inches. To calculate our relative error, we'll take 5 inches, divided by 520 inches, and then multiply by 100%. 5 divided by 520, and then times 100, gives me 0.96153, and so on. Our measurement number had 2 significant digits, so we'll round this to 2 significant digits. That would be 0.96. So 0.96%. Our smallest possible value would be 520 minus 5 inches, so 515 inches. And our largest possible value would similarly be 520 plus 5 inches, or 525 inches. Okay, let's just do one more. Here we have a measurement of 32,500 kilograms. Neither of these ending zeros are marked as significant, so this measurement number is precise to the nearest 100 kilograms. The greatest possible error then would be half of that, or 50 kilograms. To find our relative error, we take our greatest possible error and divide it by the measurement number itself, multiplying by that 100% to make a percent. 50 divided by 32,500, and then times 100, gives me 0.153846. This measurement number has 3 significant digits, so I'm going to round this to 0.154, because I need to round up because the 8 follows. So 0.154% for my relative error. The smallest possible value would be this number minus 50, so 32,450 kilograms. And my largest possible value, this number plus 50 kilograms, 32,550 kilograms.